On October 23, 2025, this was almost nothing. A weak smudge of clouds in the Caribbean, a tropical depression that the official forecasts gave maybe a Category 1's worth of menace. 5 days later, it slammed into Jamaica as a Category 5, with winds of 185 miles an hour. At its peak, it tied the strongest Atlantic hurricane ever measured. Her name was Melissa, and the thing that makes hurricanes so deadly isn't just their strength, it's how fast that strength can appear. Melissa's winds nearly doubled, from about 70 to 130 miles an hour in a single day. Forecasters call that rapid intensification, and for decades, it's been the hardest problem in the science, the holy grail, the thing the models almost always miss. Almost every model missed it this time too. They couldn't agree on how fast Melissa would explode. Except one. It wasn't a government. It wasn't a supercomputer the size of a building. It was an AI built by Google DeepMind. And 5 days out, while Melissa was still barely a storm, it put the odds of a Category 5 landfall in Jamaica at 80%. 3 days out, nearly 100. That early warning is the whole ballgame. Jamaica opened hundreds of shelters, evacuated the coast, pre-positioned supplies, days ahead, not hours. As the head of Jamaica's weather service put it, with early evacuation and better preparation, it does actually save their lives. Melissa still killed 95 people across the Caribbean. No forecast can stop a Category 5. But for the first time, the most accurate call on that storm, days before it struck, came from a machine. This is the story of how the best hurricane forecaster on Earth stopped being human, and why it matters for the season that just started. For 100 years, forecasting the weather has meant one thing. Physics. You take the laws of the atmosphere, fluid dynamics, thermodynamics, write them as equations, and solve them step by step on a supercomputer with tens of thousands of processors. It works, but it's slow. It's enormously expensive, and the storm is moving while you compute. DeepMind did something almost heretical. They threw out the equations. Instead of solving the physics, their models learned the weather. From roughly 40 years of recorded history, millions of observations of how the atmosphere actually behaves. The AI never solves an equation. It recognizes a pattern. When the sky looks like this, here's what tends to come next. And the speed is almost absurd. A traditional 10-day global forecast takes hours on a supercomputer with hundreds of machines. DeepMind's model does it in under a minute, on a single chip. But raw speed isn't the trick that caught Melissa. This is. The atmosphere is chaotic. A tiny nudge today becomes a huge difference next week. So instead of one forecast, the AI runs the storm 50 different ways. 50 possible futures, each physically plausible. Think of it as 50 parallel universes of the same hurricane. Where those universes agree, you can be confident. Where they fan apart, that's your uncertainty. Measured, not guessed. For Melissa, an unusual number of those 50 futures pointed at the same terrifying outcome. Rapid intensification all the way to Category 5. That agreement is what gave forecasters confidence days early. DeepMind's experimental cyclone model, the one watching Melissa, was trained on the records of nearly 5,000 real hurricanes from the last 45 years. And on its 5-day track, it lands on average 140 kilometers closer to the truth than Europe's leading model. That's a day and a half of accuracy that normally takes the field a decade to win. And this AI doesn't replace the science it beats. It still leans on the physics underneath to know where the world is right now. It's a faster, sharper lens bolted onto a century of work. Now, a Google blog post claiming Google's AI is amazing isn't proof of anything. So here's the proof. James Franklin spent his career at the National Hurricane Center. A former branch chief, the human, who used to run the forecasts. He's retired now, with no horse in Google's race. After the 2025 season, he ran his own analysis of every model. His verdict on the DeepMind system? It was the best guidance we saw this year. Across the whole season, he found it beat the other models on both track and intensity. Not on every single storm, it stumbled on some, but overall, the best guidance available came from the machine. CNN put it bluntly in December. The best hurricane forecasts of 2025 came from an AI model. And the reason forecasters were so struck wasn't the track. It was that holy grail again. For the first time, an AI was reliably calling rapid changes in intensity, the thing physics models had failed at for 40 years. The Hurricane Center didn't just admire it from a distance, they cited the DeepMind model directly in their official discussions as Melissa bore down. But listen to how the forecasters themselves frame it, because this is the honest part. AI just is an amazing tool, one senior specialist said, but it makes mistakes. It has errors, just like every other approach. Franklin called it a black box. It looks for patterns in past data. It's not tied to physics. It is, in their words, a new tool in the toolbox, a spectacular one, not a replacement for the human at the desk who still signs the warning. So, who built the box? Meet Remy Lam. And notice what he is not. He's not a meteorologist. He never trained in weather at all. He's an aerospace engineer. He came up designing optimization methods, earned a PhD at MIT building algorithms to make airplanes better. His whole background was teaching machines to find the best answer in a sea of possibilities, which, it turns out, is exactly what a forecast is. When Lam and his DeepMind colleagues claimed you could beat the world's great physics supercomputers just by learning from data, a lot of serious scientists rolled their eyes. It sounded like Silicon Valley arrogance. Weather is the original chaos problem. People have devoted entire careers to those equations. Then, GraphCast landed in the journal Science and beat Europe's gold standard model on more than 90% of the things it was tested on. A year later came the ensemble version in Nature. The skeptics started to come around when DeepMind's earlier work was put in front of dozens of professional forecasters in a blind trial, and they preferred the AI. Lam's own words capture how fast it moved. It's like we've made decades worth of improvements in 1 year. In 2024, Nature named him one of the 10 people who shaped science that year, the AI weatherman. He won British engineering's highest honor. He didn't set out to forecast hurricanes. He set out to teach a machine to see patterns humans couldn't. And the pattern it learned to see, earlier than anyone, was the shape of a catastrophe. To understand why that's such a big deal, you have to know how long and how desperately we've been trying to do it. September 8, 1900, Galveston, Texas, a booming island city. By the next morning, it was the site of the deadliest natural disaster in American history. Somewhere between 6,000 and 12,000 people died in a single night. The most cited number is around 8,000. A 15-foot wall of water swept over an island whose highest point stood under 9 feet. Here's the part that haunts. The warning existed. Forecasters in Cuba had it right, tracking the storm into the Gulf, toward Texas. But the U.S. Weather Bureau, distrustful after a war, had banned the Cuban reports. And the local official, a man named Isaac Klein, had years earlier called the very idea of a hurricane destroying Galveston an absurd delusion. He'd argued against building a seawall. The storm took his own house, and his pregnant wife with it. The better forecast was out there. It just never reached the people who needed it. Galveston didn't die for lack of a storm. It died for lack of warning time. 22 years later, a British physicist named Lewis Fry Richardson dreamed of fixing that with arithmetic. He imagined a vast theater, its walls painted as a map of the Earth, filled with 64,000 people doing calculations by hand, all racing to compute the weather. He even tried it once himself. A 6-hour forecast took him 6 weeks, and it failed completely. The dream was right. The machinery didn't exist yet. It arrived in 1950 on a machine called ENIAC, the first electronic computer. 17,000 glowing vacuum tubes, a team led by Jules Charney and the mathematician John von Neumann ran the first computerized weather forecast. And it worked, barely. It took the machine about 24 hours of computing to finish a single 24-hour forecast. The computer could just keep pace with the sky, no margin. But it was proof the dream could run on silicon. From there, the slow climb. For decades, forecasts gained roughly 1 extra day of accuracy every 10 years. Patient, hard-won progress. And then, In a single year, an AI learned to see a category 5, 5 days out, 50 ways at once, faster than the supercomputers, and better, 125 years to buy back the time the people of Galveston never had. The 2026 Atlantic hurricane season opened on June 1st. America's weather agency expects a quieter than normal year. But quiet is a statistic, not a promise. It only takes one Melissa. And this is the part worth being honest about, because it's where the story gets more impressive, not less. These AI models have a real weakness, and it's a profound one. They learned from history. So when a storm is truly unprecedented, a record breaker, the likes of which the data has never seen, the model is at its weakest. Peer-reviewed studies showed it. Strip the strongest hurricanes out of the training data, and the model simply can't imagine them. For the rarest, most extreme events, the old physics models still win. Which means Melissa wasn't the AI working in easy conditions. It was the AI succeeding precisely where it was supposed to fail. And it isn't just Google. Europe's Weather Center built its own AI forecaster, now running operationally. So did labs in China, and at NVIDIA, and at Microsoft. This isn't one company's trophy. It's the whole field crossing a line at once. The human forecasters still issue every warning. The physics still runs underneath. AI didn't replace the system. It supercharged it. And here's the most hopeful part. Because this runs on a single chip instead of a $100 million supercomputer, the best forecasting on Earth is suddenly cheap. DeepMind open-sourced the core model. Flood warning systems built on this AI now reach hundreds of millions of people across 80 countries for free days ahead. Researchers are mapping out how a country with no supercomputer, no radar at all, could run a world-class forecast for the price of a monthly subscription and deliver it to a farmer over a messaging app. The countries hit hardest by storms, the ones who could never afford the best forecast. For the first time, they can. For 125 years, we've been trying to buy time against the sky. And this year, quietly, a machine that taught itself the weather started winning and started handing that time to the people who never had it. The storms aren't going to stop, but for the first time in history, we're learning to see them coming. And that, not the machine, but what we choose to do with the warning, is what saves lives.